All right, let's solve the today Leetcode problem. Even though we are having a honeymoon period for like 2 easy questions for 2 or 3 days, now we're getting a hard question. So, all right, at the end, we still need to take care of the legal question anyways. So the legal questions set in the session site at least 2. So we are given a 2D array integer array of intervals where the intervals of I mentioned like start to end, which should represent all integer from the start to the end inclusively. That means we are given like integer array like 1 and 3. That means the interval include from 1 to 3. So a containing set is array number which each interval from intervals had at least 2 integers in number. So we have to choose the containing set. So each interval that is given in our inputs intervals must include minimum 2 points for the containing set. So we have to return the minimum possible size of the containing set. So let's go for some dry run about how the HTML work. So even though it's a hard problem, after we understand like given a bunch of interval like pick the smallest number for integer, such as every interval containing at least 2 of the number we pick. So what we need is, according to the given question, we need to have at least 2 of our point in every interval. So that is the minimum number of point we can place. So let's go for the HTML1. So we are given like 1, 3 in here. Let me draw in one color. 1, 3 in here. Second is 3, 7. And then that is 8, 9. All right, it's a little bit ugly. Bear with me. Should be okay. Okay, how are we going to calculate it? So we are checking the points in here. Let's consider like we measure the 2 points in here. So we are given that we can take a lot of possible approach. How can we take it? Like we want to take it 2 points, 1 and 2, which is also can consider the containing set. And then next is a 4 and 7. And then next will be 8 and 9. That will be total number of 6. So every interval we involve the 2 points, which is the containing sets. So to optimize it, what we really want is we need the minimum possible size of the containing set. So how can we achieve it? So instead of taking like randomly choosing the number, we need to choose precisely for the interval points. Since 3 is overlap between the first interval and second interval, so we can choose like 2 and 3 for the first interval. Let me mark this as one color. And then we will also choose like 3 and 7. So since this is a green, so 3 and 7, that will be the one interval. So even though after we choosing the coordinate set for the 2 interval, we only selected 3 numbers, and then 8 and 9, which is a totally separated interval. So we have to choose anyhow. So that built as the total number of 5 outputs in here. So let's consider like there's an interval from like 1, 3, 1, 4 to 5, 3, 5. That means we have the interval from 1 to 5. Let's try to draw it. So 1 to 3 in here, and then 1 to 4 is also in here. And next is 2 to 5. So 2 to 5 is from here to there, and then last one is 3 to 5. How are we going to choose the minimum coordinate intersection set for these 4 interval? That's really straightforward. We need to choose the thing that is overlapped across each interval. So if we check that the values 2 is overlapping the 3 intervals in here. And the next is the 3. So which is also overlapping with the first interval and last interval. So even though they are overlapping between the first and last, they are also covering the second and third intervals. And then, last but not least, we're gonna choose the last interval as a 4. So that's going to cover like everything for us. And then that's the reason we got like choose the 2, 3, 4, and then the answer became here. So yeah, that is for the assignment 2. And let's try one for the assignment 3. Gotta move down. So in the assignment 3, we are given like 1, 2 in here, and then 2, 3 in here, and then 2, 4, which is here. Last but not least, it's just a 4, 5. So how are we going to choose? So in that case, since we have to involve all the minimum, since 1 and 2 is only 2 values, we have to choose for sure. 2 and 3 definitely need to choose because we need to involve all the intersection point for the each interval. And then we have already covered for that interval already, which is 2 and 3. So last thing we need is to cover the 4 and 5. Even though we have covered like 1, 2, 3 in here, since the last interval 4 and 5 is look like a totally separate entity, there is a reason why we have to choose the 4 and 5. That's why the answer, final answer for this assignment 3 became the 5 in here. So this is just a logic understanding of the problem, and the way how we can solve it is quite straightforward. How we can do is we can simply solve the given interval by using the endpoint of each interval. So maybe I will dry run with the writing the code parallelly. So before we start, what I'm going to do is I'm going to sort the intervals. Since if you see the assignment here, these intervals are sorted technically, but we are not sure it's sorted in which kind of order. So there will be the chance like, what if we are having the, okay, I will show the assignment first. I'm gonna return the -1 in here. So let's create the one variable called count. Then 0. I'm gonna return the count here. So what I want to sort is I want to sort the intervals by using the sort API from the Swift, and then that would be A and B in. So what I'm going to do is I don't want to use the A and B. I can simply use the $sign in here. If you are used to the Swift, $sign means the first parameter, $1 means the second parameters in Swift. And then we're gonna check the 1 is not equal to second parameter of 1. While we doing the 1 in here is we are technically checking, should be the $1. 2 items, let's call it like here will be 3 and 7. We are comparing like the 3 and 7s are not the same number. If you run through or skim through the number, there's a case like these numbers are same. If these two numbers are same, what we need to do is we need to compare with the other approach. So let's say if two numbers are not same, what I'm going to do is I'm gonna compare the first item of start is less than to the second item of start end. So it's a little bit complicated. So we are comparing like we want the order is the ascending order. Okay, I will just write the code and I will do the visualization, which will be easier for us to understand the question much better. And then b of that shouldn't be would be 1, 0. That should be also to 0. Okay, what I'm going to do in here is I'm going to just print the sorted item for you guys so that you can see what I'm doing in here. So if we are receiving the 133789, that's we are simply sorting the interval by using the endpoints, which is the 3, 7, and 9 in ascending order. So if we move to the second XML, we are given a 1, 3, 3, 4. So that's pretty straightforward, 1, 3, and 1, 4, because this is ascending order between 3 and 4. So now we receive the 5, 2 same endpoint. What I'm going to do is I want the interval that have a greater starting point in the frame. So that could save us a lot of time when we are doing the comparison between the two-point approach. All right, after we receive it, we're gonna create the two-point approach in here. Let's call it, instead of using a pointer, how about we call the rightmost pointer, which will be the -1 in default. I will call this one the second rightmost. So that is a little bit longer variable name when compared to the other solution that I have done in the past. So the reason why I want to create the longest variable is I want to be able to most understand if you are starting to solve the problem for the first time. You don't want you guys to be dependent. So let's call like interval in sorted interval. What I need to do is I need to create the start and end point because I don't want to use every place like interval of 0 or interval of 1. Let's call like start and end, which will save a lot of time for us and less error prone during the program. So let's call it like if the start point, if I mean the start point mean like 1 in here, 2 in here, 3 in here. So the start point is greater than the, let's call the rightmost pointer. So what do I mean by that, the rightmost pointer? So if we are choosing the two numbers in here, let's draw the XML like this. Follow the XML1. So this will be the 1, 3. 1, 3 is in here. I will create like this. That's a little bit ugly. Bear with me. And then 3, 7. 3 to 7. Next will be the 8 and 9. So I am going to use a two pointer in here, which will be the one. I don't know how to make this one large. This is the largest. Okay, if you see the right one, there's a pointer 1. If you see the green color one, there is a pointer 2. All right, I will write down here for you guys. All right, continue our program. What I'm going to do in here is we are trying to compare our start pointer in here with our existing pointer. So initially, all our pointers are here, minus case. So no matter whatever we are comparing is, it's going to measure for the base case. Let's write like current interval starts after both point. Let's call it this. And then what we're going to compare is if the start is greater than the rightmost pointer, means true. So start pointer mean like we are starting from 1. So 1 is bigger, then it's true. What we're going to do, we're gonna count to 2, which will be our answer. Because that literally means we are taking the 2 points in here. how do we take the 2 point? It's pretty straightforward. For the pointer, let's call it second rightmost pointer. Now you will be make sense. Second rightmost pointer mean we are taking the green one in here. So mean like we are simply take the second rightmost pointer by detecting the n minus 1. So in n mean like 1 to 3, we want to take the rightmost, which is the nearest to the n. That's why it's called second rightmost. And then the rightmost pointer will be n. That's pretty straightforward. Here, so this is a B1. This is a rightmost pointer. So we had already taken the 2 and 3. So next, what we need to do is we need to check the condition again. We are going to compare the start pointer, which is all the initials in here. We're going to compare this time with the second rightmost pointer. So if the start is greater than the second rightmost pointer, that means start after the second rightmost. But before inside rightmost pointer. That will be a little bit complicated. Okay, let's go forward. Now we have two values in our n. So the rightmost pointer is now, let's call it 3. We are going for example 1. The second rightmost pointer is now like 2 because we detect the 1 from n in here. And then we go to true again. Now it's time for the second interval, which is start will be the 3 and then end will be the 7. And then our count in here is already 2. Since it's matched with our fact if condition, and then we plus 2 to the count, and then that is the reason why count is 2 at the moment. So if we move to the next step, we're comparing the 3 is the start, and then second rightmost pointer will be like that. So 3 is greater than the right start will be the 3, yeah. And then comparing the rightmost pointer is also 3, which is going to cause the false. Why? Because this is overlapping. We don't need to take it. We cannot take it. So if come to the else point. So we compare it in here again. So start is a 3 in here. Our second rightmost pointer is 2. Then that condition is correct for our case. What we're going to do is also pretty simple. We're gonna take only 1 for the count. Why? We are already overlapping here, so we don't need to move that pointer anymore. And then what I'm going to do is second rightmost pointer will begin the rightmost pointer. Alright, what I'm doing here is I'm swapping the second rightmost pointer is here. This one, green. I'm moving the green from second rightmost pointer B2 to here to there. And then next step will be I'm moving the rightmost pointer to the end. So end means we are moving to here. So that's what I'm doing exactly. And then there we go. We updated. So since our second rightmost pointer is now value is 2, no, we have to update. Okay, our rightmost pointer is 3, so we assign to the second rightmost pointer become 3. So our rightmost pointer now became 7. And then our count became 3. Because we do the plus 1 here. Then next will be the 8 and 9. We are now in the last interval of the example 1. So the same, we compare again. We compare the 8 with the rightmost pointer, which is a 7. This is true. And then we're going to take all. That is how we receive the answer of 5, and then we just return it. So let's try to run it out and see how it solved the problem or not. Yep, it's solved. I did for the time complexity, that would be the O of n log n. The reason why I'm saying O of n log n is we're doing the sorting in here. Let me check what did I do wrong in here. There must be something wrong in the conditioning. Second rightmost pointer is becoming rightmost pointer. I think I do there's something wrong with the sorting. Let me double check. Oh, that should be the wrong. All right, my bad. All right, I will try to print out the sorted item again. So let's double check, is our assumption correct or not? So according to this examiner, so if these less endpoint interface are same, we need the highest start point to come first. So we are ascending in descending order. The same if it is, okay, this is a bad example. Okay, let's try to submit again. Yep. So for the time complexity sake, that will be the O of n. The reason why is that n, not O of n, is the n log n. So the reason why it became the n log n is we are doing the sorting here. So sorting in Swift is taking the n log n. So that's the reason why we are receiving the time complexity is the n log n. For the speed complexity, that will be the O of n, since we only take the same array effort as the interval. Yep, I think that's pretty much of it, and then see you in the next one. Bye.